Okay, so let's carry on where we stopped last week. So basically, last week we ended with some of the Z values. If I give us a Z value, how we need to work out the probability. If I give us probability, how we work backwards. So today we just continue with that. We'll also get into confidence intervals, hopefully, and those kind of things. But it's basically the whole time we're looking and working with a Z. Sometimes we're gonna include the T for the next few chapters as well. But it's basically looking at those kind of calculations. Okay, so let's look at the next one. And let me just get my... Okay, so in this, they tell us consider a normal random variable. So then one can start looking at, one works with a Z, but let's just see what else they give us before we make that decision. With a mean of 300,000, standard deviation of 1,800. Calculate the probability that the random variable is at most 3,800 and choose the correct answer from the list below. Okay, let me just... do this again so that we can see what the at most also means. Okay, so basically they tell us we need to just get the final one. We need to calculate the Z. We'll decide what that is now, and the Z we normally and with this part there's still no sample, so it is still the normal sampling distribution that we are looking at, and they tell us calculate the probability at most. So let's then look at the at most. Okay, so we're looking for smaller or equal to. Okay. So just again, at most means that one that we're gonna look at, which will make a difference in this. So if we look at different, interesting, nothing really adds to one. If I look at two of them, that adds to one. So it will be interesting to see what the answer will be. Okay, and then we've got it's way too early in the morning for me to, I thought it was too, was the same. Calculate probability that the random sample is at most that. And they give us a standard deviation of 1,800. So it's basically 3,800 minus 3,000 is 800 divided by 1,800. So if we do that calculation, the z must be smaller than 0, okay, basically 44444. I just want to see if that everything that I'm doing is correct. Okay, so the first thing I would do is, again, before I even go to the table, we know that if that part is 0, 0,5, so if I've got a z of 0, and let's just say 444, whatever this value is going to be, it's going to be bigger than 0, 0,5. So I just want to narrow it down. So that is not bigger than 0, 0,5. That is not bigger than 0, 0,5. Not bigger. So basically, I'm sitting with two options that it can be. So then we need to go to the Z table. Let me just see if it is in this folder. You can see if I've got lots of. Okay. So let's open the. So again, the lecturer is working on one document for you guys that will have the scope and all the tables and all the formulas in, and hopefully we will get this early in the week. So let me just get to the Z table. And we're looking for a Z of 0.44. So let's use this table that because we want in any case that area. So 0.44. So 0.44 is 0.67. Okay, 0.67, and that was option 1. Okay, so again, how I would do it in the exam is I would first draw myself this diagram as well, just to make it a bit simpler and to see which ones I can actually cancel out. Because there's basically, then if you don't know how to use the Z table, then at least when you guess it is between 2 and not between 5. Okay, so let's go to the next one, and let's again see what information they give us. So let's just make it a bit bigger. Okay, this doesn't need to be bigger, only, okay, that didn't. Okay, cool. Okay, so upon conducting further research prior to organizing scholar transport, the Education Department found that learners travel time from home to school at one of the remote rural schools is normally distributed with a mean. So we can see that the mean is 140 minutes. Standard deviation 72 minutes. What is the probability that learners' travel time from home to school is less than? Okay, so probability that we need to work out, Z less than 100. Okay, the one other important thing nearly in this one is just be very careful in the exam, in a question where they use minutes, that they don't maybe ask then for you to work out in, say, less than 2 hours or something like that. So that you, when just make very, very sure when they talk for 1 unit, that when they ask a question for you to work out, that it is also in the same unit. Sometimes they do say less than 2 hours maybe, and then you use for 2 instead of 120 minutes or something like that. So just be very careful when they talk about minutes in any question, that they don't use hours as well somewhere, that one can maybe use the wrong numbers. Okay, so from this basically then we need to say the 100 minus 114, which gives us minus 14, and that divided by 72 will give us around, I'm first going to write down the whole 4, which will then give us minus 0.19. Okay, so then if we look at the table where that is Z, and we say that in the middle, so that is Z0, the minus 1.19 will sit somewhere here. So again, we, like I did in the previous, so let's just now shrink this to full screen. So now I know this area that we're going to look at is going to be smaller than 0.5. Just because at the middle, that area will be 0.5, so I'm losing a bit. So this area will be smaller than 0.5. So because this area is going to be smaller than 0.5, that one will not be one of the options. That one will not be one of the options. And that one will not be one of the options. Okay, so then we're basically sitting with 2 that it can be. We go to the table, 0.19, and let's just minus 0.19. Okay, 0.19. And it is looking at that small area, so it's perfect that we just read it off the table. 0.4247. 4247, and there we have the answer, so that one would also have been wrong. Okay, so once again, nearly when you draw the diagram, you can see that it definitely eliminates some of the options already. So just as a near tip for you to see which ones we can actually eliminate. Okay, let me just do a quick check-in. Is this all right? Is the questions about the first 2 that we've done happy on that?
Happy from my side, thank you.
Okay, cool.
Yeah, happy.
Thank
Thank
you,
you.
Jane.
Okay, awesome. So let's continue. Okay, so again, one of these, but now you see that again the question is a bit different. Consider again the findings. Okay, one of a school is normally distributed with mean 114, standard deviation. An education consultant has recommended no more than a certain minutes of travelers or learners' travel time to school. If a department would like to ensure that 15.15% of learners adhere to the recommendation, what is the recommended travel time? Okay, this is quite an interesting one again. Okay, so let's just first also get that table back in if it is needed. And let's see what they give us in this one. So let's just do that as well. Then at least it's a bit bigger. Okay. So they give us the mean. Again, it's 114. They give us the standard deviation. Okay, so basically, if I'm reading this correctly, they tell us that the probability no more than um, okay, and we need to work out the x in this one. Okay, so how would we do that?
Would you first try and get rid of the 72?
Okay, so before we do that, what is this equal to? Or is there a way to get to the z?
Yeah.
Okay, Christina, what
They've
would you
given
do?
They have given you the probability, so they've given you the z value, which is another variable you need when you rewrite the formula to calculate the missing x.
Okay, so, and how would you get that z value?
So first you'll need to convert that 15.15% to decimal. So 0.1515 would be the value I would go and find on the z table.
Okay, cool. Okay, and because it's small or equal, we can actually go to the positive table because that will be small or equal. So in these numbers, okay, so it will be easier to get the number in the negative table and then convert it over into positive. Okay, so else you could have done it in this table, but then you would have needed to say 1 minus 0,1515. Okay, so if you wanted to use this table, you would have needed to say 1 minus 0,1515, which will give you 0,8485. So you would have gotten 1,03, or you can use the negative table and just rewrite it as a positive. So 1515 is then 1.03. Okay, so we can rewrite that as 1.03. And then I think Rory, you said it, when we get rid of that 72. And how to get rid of that 72 is we multiply on both sides with 72. So the 1.03 times 72. On this side it's 74.16 if I multiply those two. On this side the 72 will disappear, so I'm sitting on this side then with x minus 1. Okay, yes. What am we missing here as well? Okay, this is interesting. So I followed the right process, hey?
I used the negative z value when I did this in the assessment.
Yes. So and let's just say no more than. So you would have said that.
Yes.
Yes. Okay, so, and see, I didn't draw my table. And because I didn't draw the table, or my diagram, so that will be. Okay. So again, if you draw the diagram, you will not make that mistake. Else, very easy to make that mistake of taking the wrong value. Luckily, in this instance, if I worked with the positive, there wasn't an answer. That's why I was like, what did I do wrong? Okay, so then to get rid of 114, we add 114 to both sides. So minus 74.16 plus 114 gives me that x is 39.84, and then all of these are approximately, so the closest to that is approximately 40 minutes, which will then give you option C. Okay, so what is important with this one, and I want to include a new slide. So how it so when we look at this, and even if we later add the n as well, the normal way for them to ask it is by giving you that, and that, and you calculate a z. And then you go to the table and you say, okay, all my z is positive. I look at the positive table if I need to get that area, or maybe my z is negative and I want that small area, and I go to the negative table. The other way that they can ask it is by giving you a probability. And with that probability that they give you, you need to go and find a z value and then use that z value in this formula where one of the other three will not be given, so you calculate one of the other three. Okay, so then when we get to study unit 7 and we have a formula where we add the n, because we then go into sample distributions as well, the same can apply in this instance where they give you, normally they give you those four. You need to calculate a z so that you can get to a probability, but it can also be that they give you a probability and then you need to calculate one of these, like we did now for this one of just this, the normal standard distribution, but it can be that we also need to do it for the sampling distribution. And that is nearly the two ways that they can test it in study unit 6 and 7 if they give you that information. Okay, so in this instance, in the normal distribution or normal standard distribution, we basically needed to work out the x. They can also ask you to work out the standard deviation or the mean. So it is any one of these three can be an option for them to ask you to work out. Okay, so this was the other one that I thought was interesting. Yes.
Sorry, that previous one really confused me.
Yeah, and I think that is nearly what one must be very careful in the exam, what they ask and what you need to do. So what I would do in the exam is because I normally, what I would do is I would write down this formula. Or then the other formula that is divided by the square root of n. And then I would start populating it with the information I have. So I think it was, and what was it, 74. So I would nearly do that. And then I would have the question marks. Okay, I don't have that. At the moment, I don't have that. So I would nearly first do that, and then I'll see, okay, but if I don't have the X, do I have something that can get me to the Z? And then, like you said, it is very confusing because now you sit with 1, 5, 1, 5. And again, very easy for you to make the mistake like I did. What now is that 1, 5, 1, 5? So that's why I didn't start off with it in the previous one, so I would then say, okay, they tell me that is the probability. So where, if this is all equal to 1, where does that 0, 1, 5, 1, 5 sit? It must be on this side. So that area is 0.1515.
because it's negative. And I think that's what I also did, forgetting to put in the negative.
See, and that is because one is so focused on getting to the 1515 that you nearly forget what you're also working with. So when you draw it on this, where that is 0, it needs to be negative, because now you can see it. This side is negative, that side is positive, so it will fall on the negative side. And that is nearly the biggest mistake that one can then make, is make it positive. But luckily for the positive this time around, there wasn't an option. But again, as we know in the exams, there will probably be the positive. If we used the positive, then that would have gone over, and then you sit with something like 190 or so. There would probably be in the exam an option if you use the positive. But I think it's so, and the problem is also in the exam, you don't always have the luxury of time to go and sit and work this out. It's the same with the next one that we're going to do. It's you don't with these ones. It's easy. You follow a method of working, and you get to the answer. With these other ones that nearly you need to think what you need to do, and that is, I think, for the exam also the problem then with timing is that when it's not the normal one, it takes a bit of time to nearly see what you need to do. So in this question again, it's not the traditional way that we normally look at it. So let's again see what in here. The emotional intelligence quotient score of high school learners is normally distributed. So we know we work with a Z, with a mean. So we have a mean of 80. We have a standard deviation of 20. If there were 2969 learners with scores higher than 95, how many students took the EQ test? Okay, so they tell us there's 95. So that is the odd one out. What do we do with that? Okay, so higher than 95. So when we work out that Z, let's see where that will end up. So let's first work out the Z. So Z is equal to 95 minus 80, which is 15. 15 divided by 20 is 0.75. Okay, so 0.75 is bigger than 0, so it will, let's say it sits somewhere here, 0.75. Okay, so higher than 95, so we want to see what that probability is. Okay, so I want to get to that area, so you can do it two ways. You can go to the positive table. The positive table, we will, at the 0.75, we will find this area. Then we need to say 1 minus whatever we get for this area, and we will get that area. So let's do that. So 0.75, 0.775, okay, 0.7734, 7734. So if we say 1 minus 0.7734, we get that probability of 0.2266. Okay, so that area is 0.2266. We could have also used the negative table of 0.75. So if we set minus 0.75, we could have gotten that smaller area. Let's see, 75. Okay, 2266. And because we know that with normal distributions there's symmetry, that would have given me the same number. Okay, but now we have that. And nothing in here tells me, and nothing what we need to do tells me, okay, this is now what I have. So the way that we now need to solve this is that we need to say this area is equal to that. So, and this is I must say, this is one of the most difficult questions that I have seen. So this area is equal to 2969. So how big is this whole area? Okay, so if this area so this area of 0.2266 is 2,969 students. So how much is the whole area? So we need to get to 1. Okay, so the easiest how I did it.
One sec.
Sorry. haven't activated Siri on her side. So the easiest way for me to do it is to say that the 2969 divided by the 02266 will give me the full number of students, which would have given me 13102 comma something, which is equal to that one. So this was, for me, one of the most difficult ones because, and let's make a bit of room again here. So what we did was basically to say this area that we calculated, in that area there is 2,969 students. So if that area is 0.2266, how many students is in this whole area? And the way to do that is to say 2969 divided by that population to get to the total one. So this is really what was for me a very difficult one, because it really to get to the understanding of that small area is a certain value, and then you need to work out the whole area to get the full value. It is quite difficult. So I'm hoping that now this one does make a bit more sense than when we did it a few months ago and when you did it for the assignment as well. I hope.
Yes, it makes clear. Thanks.
Okay, cool. I just want to.
I think when they ask the questions and there's a figure missing, that's what throws me out.
Yeah, and I think that again is, and unfortunately also with your exam, you can't, because it's going to be like the assignment, you can't skip this question and come back to it, which is also a bit, but what makes it more difficult is when you get the question, you need to do it. So it's not that you can say, let me do the other ones first, and if I still have time left, I will come back to this one, where it does make it much more difficult than other exams where you could have gone back to this one again. So, and that for me is, I don't know, I don't have the answer yet how you guys need to manage questions that nearly throws you a loop and confusion, and you don't want to spend 10 minutes on this. Which, yeah, so that for me is the difficulty in some of these, that if I look at something like this one, it's nearly, if this was taking time, then it is, okay, let's quickly see that is less than, and then maybe take a guess to save time. But on this one, I was like, I can't really see how we guess something like this. And the same with this one, it is, again, I can't see how we guess something like this. Probably I would have said, if that is 2969. At least I know the rest. It can't just be a few students, probably not that. But when I'm sitting with three options, that could have been anyone, until I actually work it out. So that might be the option to say, well, if that is that small area, just to add an extra 200 students will not give me the whole. To double it up will probably not give me the whole, but then I need to guess one of the other three, to save time. So that for me is the problem still with your exam, is I don't have an answer to help you with things that one needs to skip. Okay, Christina, let me see if I can copy that image in. Then we also have it.
I'm not good at skipping steps, so I need to write everything out
Okay.
step by step. Otherwise, I mess it up completely.
No, okay, see, so that, and this is perfect. So to make, so at this step, and let's do that. So
I think what's weird with this question is that they're basically asking for n, and normally when we calculate z, n doesn't really feature.
never. So N never featured previously, in these kind of things. So yeah, so let's just, to make it, so I just needed to add the N for you to make it, because then still you isolate N on this side, it's 2969 divided by 0.2266. See, and then still you get that in the exam, there was now this one in Christina's option was still giving you the 80, the 20, but it changed the number of learners. And so it changed that one, and it changed the 95 to 91. Okay, so, but all the, okay, and then some of the answers also changed. And then the answer option also changed. So I think with this, we also now get a very good idea in the exam. The question will be very similar. So the question you could see here is asking, there's nothing in the question that changed to make it anything different. The things that they give you different is suddenly that one changed and that one changed. They still ask you some higher scores, so that all stayed the same, but they just changed two of the variables. And then obviously some of the options have changed as well. But this is perfect. So that's why I'm adding it. So again, something that you guys can just, but yeah, so this is, and I haven't seen a question like that previously in an exam. So that was the first, or in an assignment. So that was the first time I see that they actually ask you to work out N. I've seen a lot where they ask you or give you a probability, and from probability you need to work to get to the x, but it was the first time that I actually see that they ask you to work out the n. Okay, so let's do the next one and see if there's any changes. This question. A random sample size is drawn from a normally distributed population. Okay, population. So we can use it with a mean of 160 and a standard deviation of 50. Determine the standard error. Okay, so, and they do like to ask the standard error question in the exam as well, because sometimes we want to work out for a whole Z, because we nearly programmed like that to work out everything, but here we only need to work out the standard error. So the standard error is, just see that you guys can see it. The standard error is only this part of the calculation. Okay, so the standard error, we want to get the standard deviation of 50. We want to get the sample size was 120, and that's so 50 divided by the square root or square of 120. So that answer gives me 4,56, which is that one. Interesting. Okay, so here that was just referring to the mean. So that one, that was referring to the standard deviation. So that one is also definitely wrong. I just want to see how they got to those two, but we're not going to bother. Okay, so standard error is very straightforward, but we need to remember when we have this whole formula that we don't go the full route in actually working out the Z. We're only working with that part of the equation, because we do. I normally, with my questions, I write down that whole thing, because that is just for myself to remember when I need to work with it. But standard error is only that small part of the equation that we need to work out. So if I don't, in these questions, if we don't look at the standard error for the sampling distribution, just remember that they like to ask that as well. So let me just see. Okay, so let me just make a note that I do add one for you, sampling error of population, of proportion, that you also just, I'll just add a question to this next week. And if we complete within time, we can even look for one now. But also then, when we look at the standard error of the proportion, so I also just want to nearly write that down, just that again for when you need to use it, or when we look at it. And I'll take that blocks at the back away now, but basically also, so the standard error is every time the one that you're going to divide by in the Z formula. Okay, so each time, if it is proportion, if it is your normal distribution of the mean, it is basically the one at the bottom of the formula that you divide by. Okay, but I'll look at one of those to add to our questions for next week. See, so you will see that on that standard deviation, so I need to add an extra one on proportion as well. So let me just make a note that we do just add a proportion question as well, because you will get a proportion question. So again, in the exam, how you can look at it nearly is you will get about 2 questions per study unit. Then if you look at study unit 7, that talks about sampling distribution of mean, sampling distribution of proportion, you will have that split, that you will get one of each. And then if you look at confidence intervals, where if we say double up on 11 study units, you get 22. So there's scope for 1 or 2 extras from other different study units. So in confidence interval, how I normally ask it is a question where your sample proportion and sample standard deviation is known, so that you use the Z for the interval. There will be one that it is unknown, so that you can use the T, and then there's normally one for the proportion as well. Should just be prepared out of study units 7 and 8 that you will probably cover all 5 of those in the exam, because that is normally how they ask it. In numerous papers, that is the process nearly. Okay, so let's see if this one, okay, so here was obviously a correction in the exam or in the assignment, which didn't filter through to my side. So let's see what was the question and what happened here. A random sample size of 100. Sample mean. So that is again of 100. I don't like it. That is also 100. When one can easily make a mistake. Population standard deviation is known to be 15. Okay. Known to be 15. Population standard deviation, so we work with a Z. Okay, so that is at least, we know we work with a Z. What is the margin of error for estimating the 99% confidence interval? Okay, also the first time that we're dealing with margin of error. Okay, so what is the margin of error? Christina, you don't have that copied out of a textbook, maybe? Okay, so yeah, I was hoping that. so let's do the confidence interval, and then I show you the margin of error. So
I added it to the chat, John.
yeah, I was hoping that there was a screenshot from a textbook.
No, not this time.
So when you look at, and we also have if you look at, we'll just for full one, but I just want to write both of them. So this is the Z. If you look at the proportion, so that if they do this in the exam and they give you the proportion one, that we just cover that as well. So the margin of error is basically this part that you subtract or that you add to the excess. Okay, so that is your margin of error. So if you have it in the confidence interval, we would normally say, or how I look at it is, I'll plot my x in the middle. This one I add the margin of error, and this side I'll subtract the margin of error. Okay, so they just want that margin of error component. They give us 99%. So with 99%, you can use the table that is in your study guide. There they tell you the level of 99%, 95%, 90%, and for a standard, for a confidence interval of 99%, yes, this one. Let me copy that in because this is a cool one to be used. So we know the Z 99% is 2,58. Times standard deviation was 15 divided by 100. Let me just, yes, and then it is, where is the calculator? So 15 divided by square root of 100, so it's 15 divided by 10, which is 1.5. 1.5 times 2.58 gives you 3.87. So I think is there another name for margin of error? Ooh. I'll check for you. So that I'll check for you if there's another name that we just if I ask something else as well in the exam. That is slide 51. I'll check for you that. But I need to make myself a note. But I'll check for you so that if there is, Rory, another name that or another thing that they use that you know what to do, I'll check for you. Okay. I think there was a errata when the assignments was done, because now you see that it is both of them. So I think one of them changed. But again, if something like this happens in the exam, you will get, if you pick B or if you pick A, you will get the points. So in the exam, they will all let the question drop away if there's a mistake in it, or they would give you both. If you answered both answers, any of them, if you pick them, they will give you the points. But normally the question will be dropped if there is mistakes in it. Okay, then on this there was something else that I wanted to mention. So, and I think there was somebody posted on the chat this morning or last night, whenever, about binomial as well, and so where it wasn't on the table. So if you in the exam, these are the three levels that they will ask. They will not ask you 98% or a 96% or a 92% or anything like that. It could have been in your preparation or for the assignments, it could have been some of the weird numbers, but when it is in the exam, it will be the ones that is on a table or have been referenced. The same with binomial, Poisson, Z values. There will not be a probability that is not on that table. So when they do the binomial, there will not be one that is now suddenly, like on the chat this morning, of 0.62, because they actually don't want you to use the formulas. They want you to use the tables. So just as a side note, nearly for the exam, and that is why I like to copy this table in, is this is the one that you will deal with. So just if you prepare and there's a one that is a 0.98 or 98%, you will not get that in the exam. Okay, so let's make this one also just bigger. Okay, this is a interesting one, and now that I see this, I want to add a question on confidence intervals. Don't worry, I'll know what I mean with this. I just want to, so what they like to ask also, so let's first do this one, and then I'll just see. Okay, cool. So let's just first do this one, and then I'll try to explain what I meant with what I need to add a question. So the estimates below are 95 confidence interval estimates for the population mean, calculated using samples 20, 40, and 60. Not necessarily in that order, so just remember it doesn't need to be in that order, which estimates must have been calculated using the sample of 20. And again, you can have the one that says 40 or 60 in the exam as well. Okay, so what we need to do here, they don't give us a lot of information, but let's write down what we deal with. So we know population mean. So let's plus minus times. Let's just get that formula right. It is standard deviation divided by n. Okay, so basically what we have here is inverse questions, or inverse, that will be the same, that will be the same, that will be the same. So the thing that is changing the whole time is the square root of n. Okay, remember, they don't give you any other information nearly. They give you a 95%, but in this instance, they just could have set any confidence interval level, because changing that will not make any difference. So what happens to that value when n is 20, when n is 40, and when n is 60? Okay, so let's use a random standard deviation, or they don't give us anything, but let's say that was 20. So if n is 20, we would say 20 divided by the square root of 20, and we would have gotten 4.47. If we say 20 divided by the square root of 40, we will get 3.16. And if we say 20 divided by the square root of 60, we will get 2.58. Okay, so then what we'll see is, because we're working with, and again, what did we use? Margin of error. So let's use the 95% that they gave us. The 95 is 1,96. So let's say the 1,96 times 4.47. We get 8, something. 3.16 times 1,96, we get 6 point something, and then for that one we will probably get 4 point something. Okay, so you will see, as the n increases, so look at it, as the n increases, your margin of error decreases. Okay, so when we need to look for n that is 20, so that was the smallest one, your gap between those two will be the biggest. Okay, your margin of error is the biggest. So that gap is smaller than that gap is smaller than that. So in this instance, the gap between the two would have been the smallest, or in this instance, the biggest. Okay, so nearly what we're saying here is, as your sample increases, your margin of error decreases. Okay, so as n increases, that means your margin of error decreases. The opposite will be the case if your standard error increases and n stays the same, your margin of error will increase. Okay. And let's copy this in. Thanks. Okay, increase sample size. I'll make it, the yellow is a bit, that's better. Increase in sample size n, see how it becomes narrower, as we've seen. Okay, and then the opposite is true for the standard error. Okay, so they like to ask this. So they really like to ask this in the exam. So please, this is one that we definitely need to look at for the exam. They can change it in the exam, maybe that they reference standard error. Oh, sorry, standard deviation. Sorry, standard deviation, not standard error. So they can ask you in the exam if the standard deviation is changing. The other one that they like to ask, and I'll get that from one of the previous assignments, is that they keep the x similar, they keep the standard deviation and the n similar, and they change your z. So they ask you to look at a 90% confidence interval, a 95% confidence interval, and a 99% confidence interval. So I will definitely, that's why I want to add questions on that, because cool, thanks Christina. Let me copy that whole one in as well at the previous question. Then we have it also when we need to do it. Okay, so what can happen is that okay. So what we do like to do, and that's why let me just they won't really go the way to say x changes, because that nearly is the easiest one. So if x becomes bigger, then this you can just see that doesn't matter what happens there, your intervals will become bigger. So x they will never really talk about a change in x. So what they like to do is to talk about a change in your confidence interval. So then they would say, and again, they will use the standard ones. So they can say, well, if there's a 90%, 95%, and 99%, which one of the below is probably the right one? Then they normally say if that goes up or down, which one over below, or if, like we've now seen with this one, if that goes up or down, what will the impact be? And let me copy this in as well from okay, cool. So there you have that one increasing, there you have the sample size increasing. So you can add another one where you, Christina, where you do a change to the standard deviation as well. But that's for free. So this is cool. So that's nearly.
Will they ask one where the standard deviation potentially increase or decrease?
Yes.
Okay.
Yes, they can. Yes, they can. So because again, that is nearly just doing the opposite of the end. So, and that's why I have seen it in one of the previous year's assignments. So I just want to get you nearly this one and that one to show that there is other options. The one that they really like to ask is the 1995 and 99% one. And then let me quickly check where that was. It was in last year's assignment. So I just want to check. You can see just don't look too much in how I archive my things. Let's quickly, I think it wouldn't have mattered which semester, so it's probably been in the first one. Okay, let's see if it is that. I'll share this with you guys as well. I'll share this with, it was last year's assignments. So I'll share this with you. I'll just see how I can. It's a big one, so I will see how I can share it with you. Okay, see, so this is nearly, the question was, consider random X with mean population standard, assume a sample size. So those three stayed the same. Then there's changes in confidence interval. And then you need to say, is it only A that's correct, only B, only C, or combinations? But I just want to see what else. Assuming sample size, so there's your sample size one. What happens to the confidence interval? Okay, so let's quickly, so that was, just want to check, that was semester one. Okay, so in semester one, we had the confidence interval change and the sample size. And let me go to, so I'll add a few of these ones also to our workings next week. But we just cover everything. Just want to see if I'm already in semester two. Probably after this. Let's just check. So there's also standard error. Okay, so here again goes the sample size increase. Okay, so it doesn't seem like, okay. So here was another question. So sample size, confidence level. There was the three confidence intervals again. So again, you needed to say which one. So in both of these, there wasn't a standard deviation, but then there was, I think, a standard deviation in the exam or mock exam. But you can now see how many of these there was in last year's question set as well. So I'll definitely add one or two of those, but I'll send you this as well, that you can nearly look at these questions as extras, because it does give you a very good idea nearly of everything that can be asked. Okay, so from last year's assignments, it was basically these two, but I have seen in one of the exam papers the standard deviation as well. So I will look at one of those. So let's quickly copy that in and see.
This is a bit of a plug and play. I wanted to see what happens, and based on that, it looks like your range will go from, if you have a big deviation, a standard deviation, you will have a wider range, like 41, and then it will become smaller the smaller your standard deviation is.
Yes, because if that goes up, that stays the same, that whole thing will become bigger, so your range will become bigger. So yes, it's perfect. And if that becomes smaller, the thing that you multiply with will become smaller, so your range will become smaller. So it works perfectly. So your plug and play is working. Yeah, so 100%. I like this. And here you guys actually don't need to. We can use this as an example, so you don't even need to have the Excel, because here you can see if standard error goes up, or standard deviation goes up, your range becomes bigger. If in this one, your 90, 95, 99, you can see what happens to your range or your two intervals. So as the confidence goes up from 90 to 95 to 99, your range becomes bigger. So the only one that becomes smaller with something going up is your sample. So the only one, and that is because we divide by it. So the only one that becomes smaller when something goes down or something goes up, because when that goes up, the whole thing will become smaller. So the only thing that has the impact to make the range become smaller is when n increases. So here, what is nice, you actually just don't need the real numbers. You can just see the trends happening. So again, thanks Christina for this, because this nearly, you don't even need to have the Excel open. You can just use this PDF when we do it again in PDF, that you can see what's happening. Okay, so let's look at what they give us in
When
this
n goes up,
one.
then it gets smaller.
Quickly say again, Jolene.
When n goes up.
Yes. So when n goes up, your range becomes smaller. So as that becomes bigger, because that whole thing will become smaller, because you will divide by something that is bigger. So as n goes up, your range will become smaller. Also, the thing to note, and I think just when we look at as a catch, so hopefully they don't do it. Yeah, I just assumed, because that's the smallest and that's the biggest number, that range was the biggest. Just be careful that they don't mislead us with the gaps, because this is just so that, please work out the range. So Jolene, now that you said that, it nearly, I was just looking at the top, the top one and the small and bottom one, and where the top was the biggest and smallest, but it can be that they make it so that there's one small, one big in between these, and you actually need to look at the difference between the two. So just be careful in the exam. So rather work out each one of those range and see which one is the biggest or is the smallest. I'm just worried that sometimes it's easy when you see the smallest and the biggest, then the range will be the biggest number. But if that was combined with that one, maybe it could give you a different answer. So just don't be caught out in the exam when they give that and you just want to say the biggest one is the one that we take. Okay, so I think we've got 3 more that I want us to cover when we've covered a lot of the confidence intervals as well. So the Department of Basic Education earlier finding from a survey of 150 learners suggest an average travel time of 114 minutes. So I would assume that is my mean. Assume population standard deviation. Okay, so we know we can work with a Z here. So standard deviation travel time is 72 minutes. Work with a confidence interval of 95. So 95, we know the Z is 1,96. And then we need to choose the one that is closest. Okay, so this is nearly one of the more straightforward ones that we actually dealt with today. So this is straightforward. You need to work out confidence interval. So obviously that is not that is that plus minus Z times standard deviation divided by n. So here, straightforward 114 plus minus 1,96 times your standard deviation, that was 72, divided by n, that was 150. Okay, so 72 divided by 150, the square root of that is 5,8788. If I multiply that by 1,96, I get 11.52. So 114 minus 11.52 gives me the bottom number, which is 102.48, and then 114 plus the 11.52 will give me the top number of 125.52, and in the middle is the 114. Okay, so then 102.48, 125.52, so the correct one for this instance was option B. Okay, so this one was nearly the first one now in a few questions that was just how we would normally work out most of our questions. Okay, so let's look at the next question. If there is, let me just make it bigger, and hopefully also a standard set of questions. Okay, household survey based on a sample of 50 households in a small rural village found that the average household income is 3,500 with a standard deviation of 1,000. Construct the 99 confidence interval estimate for the population mean household income and choose the correct answer from the list below. Okay, so what would you guys have done here? Z or a T?
I think I would have gone for T, so using the sample standard deviation, because I feel like they will normally explicitly mention population standard deviation when that needs to be used.
Perfect. So even though they tell us the population mean household, this they would need to say that it is a population standard deviation. Or what we also can use is the words that we used in study unit 6 to say approximately normally distributed. So that is the two that they can use. So if I don't tell us it is what the population standard deviation is, we must assume that it is then sample. It's the same you will see in that first sentence, sample of with average household. Otherwise, they would have said a household survey based on a sample of 50 households found the average population household income to be and the standard deviation. So if I included the population even there, it would have been fine for you to assume that it's a Z, because then the mean and the standard deviation goes together. Okay, so we need to use the T for this instance. So the T we need to remember is 1 minus n for the degrees of freedom, the alpha divided by 2. How do we get to that alpha? So it is 1 minus 99%, which is 0,01. So 0,01 divided by 2. And degrees of freedom will be 49 because it is n minus 1. So 50 minus 1. Okay, so let's first get the t value that we're going to use. Okay, so let's see where the t table are. Okay, so 0,01 divided by 2 is 0,005. 0,005. Sure. Okay, let's see 0,005. We said T49. There better be a T49. Okay, so I get the 2,68. So what you will also notice is if you guys used the 99 from the Z table or from the other table that we have, we would have used 2,58, which is actually very similar. So you will probably see that in one of your options, it will be very close to the other one, because going from 2.58 to 2.5 or 2.68 is not a big jump. So then let's just see the formula that we use is the t. So let's first write it out, that we have all of this. So the x is for 3500 plus minus 2.68 times, so this was actually S and not, because it was sample standard deviation, divided by N. Okay, so let's quickly see what that will be. So 1000 divided by the square root of 50 gives me 141.42. If I times that by 2.68, I get 3,79. Ooh, I hope there is an option for us. So 3500 plus minus that. So 3500 minus 379 is 3120.99. Okay, so it's exactly that one. And then your top one will be 3879.01. Okay, so it's exactly spot on that. Okay, let's quickly copy that in as well. Christina, on that, can you quickly change the critical value to 2.58, please?
2.58.
And just tell me what your answer would have been then for the lower or the upper.
Okay, wait, let me just, wait, tab. Just taking a screenshot quickly.
Cool. Because I want to see if we used the Z value of 2.58 instead of the T value, if there would have been an answer for you. So if we used the Z, look at that, you would have said 3,3135.13, 3864,87. So if you used the Z, you would have gotten option C as your answer. Thanks for that, Christina. So unfortunately, if we actually used the Z, there would have been an option for you. So again, this is where it's very important to be able to identify the Z and the T. The other way that nearly for the exam is you will, here we got the Z already. So if you get more than one of these, the next one would then be the proportion or the T. So you can nearly also, in the exam, you will not get 2 questions that you need to work with a Z, unless the other one was the proportion. So that can also nearly be a identification for you when you work with it. Just make sure then that the first one that you did was correct and you're not using the other way in the next question and both of them are nearly incorrect. But it is, you will only be getting 1 per question. So, and this one was probably, if let's quickly check, was this then a proportion, else I need to add a proportion question as well. So again, just be in the exam, you will not get 2 or 3 questions of the same thing. So you will not get 2 or 3 questions where you only need to use T for confidence interval as well. Okay, but unfortunately, if we used the Z, there would have been an option for us to pick as well. Okay, so let's look at the last one that I have for today. A simple random sample size of 46 from a normal population results in a sample mean of 300 and a sample standard deviation. Okay, so that already tells me I'm working with a T. So this one is actually quite not straightforward. We still need to know that what we're working with. So here, and the confidence interval is different. So we need to still get alpha divided by 2 and degrees of freedom. So degrees of freedom would be 45. The alpha would be 0,1. 0,1 divided by 2. So 0.1 divided by 2 is 0,05. Okay, so we need to work with degrees of freedom 45, 0,05. Degrees of freedom 45 and 0,05. Okay. 1,679. 1,679. 1,679. So if you also look at, if we used the Z for 90%, the Z would have been 1,645. So again, nearly very similar, and these ones are very close to one another. So again, very easy if we use the Z to also make the mistake. Okay, and then we nearly have all the others. So your sample is 300. it is plus minus your t times the sample standard deviation of 50 divided by the square root of n. Okay, so then your plus minus, and I'll copy what Christina did now as well. So 50 divided by the square root of 46. So that is 7,3721. Multiply that by 1,679. So that gives me plus minus 12,377.8, and dependent on how many they go, we change it to 3 or 4 in your answer. So again, 300 minus the 12 gives you 287,62. So there we have that number, and the top one will be 312.38, which gives us option C.
The answer would have been very close if you used the Z formula instead of the T formula.
And what would have
just the decimals would have differed? I'll quickly copy and paste.
Okay, so then at least there wasn't a different answer that you could have picked. So that at least is some positive. That and what is also interesting, so if we used the Z, come on, used that one, yeah, so very close. And in the exam, you will not likely get those two options because they are so similar. So in the exam, you won't get a 2,87.6 to 2,87 point. So just in the exam, you won't get it that close. The reason why this one, the impact is so, why the impact is so small is because this is so small. So look at, where was the previous question? So with 1,000, that impact of only a few decimals made it 12,300. So if this was 1,000, then that impact would have been also 12,300. Here the impact is very small on that, using the wrong one. So here actually I would have, in the exam, if I got the previous one that Christina had as 287,31, I would have just said, somewhere I made a rounding off, and I would have gone for option C in any case. So luckily in this one, you would have gotten one that is very close to it. Okay, so that I need to add one for confidence interval for proportion as well. So I think we must just make sure that we cover that as well. So that we know that in the exam we have covered everything for you. Okay. So that again is it for today. So we nearly, next Saturday will be our last Saturday session. I will schedule for us in that week before, or in that week that you're writing on the Friday, I will schedule us 1 or 2 sessions in that week. Probably I'll say we'll do the Tuesday a full on session like that, and then the Thursday a check-in that is just open, that we don't go through any work, but any questions that you still have before you write, we'll have like an open session on that Thursday, just to any queries that you still have that you can ask. Okay, but that we'll schedule closer to the time. I am also following up on the lecturer to get the formula, the tables, the scope, all of that we get that as quickly as possible. So he is working on it to hopefully give that to us within the early part of the week. Okay. Thanks everyone. Have a good weekend, and I'll put this on